Now discuss regarding design consideration in distribution system. Good voltage regulation of a distribution network is probably the most important factor responsible for delivering good services to the consumers. For this purpose, design of feeders and distributors required are careful consideration. First one is feeder. A feeder is designed from the point of view of its current carrying capacity, while the voltage drop consideration is relatively unimportant. It is because voltage drop in a feeder can be compensated by means of voltage regulating equipments at the substations. Second one is distributors. A distributor is designed from the point of view of the voltage drop in it. It is because a distributor supplies power to the consumers and there is a such statutory limit of voltage variation at the consumer terminals, plus or minus 6% of rated values. The size and length of the distributor should be such that voltage at the consumer terminal is within the permissible limit. Next, classification of distribution systems. A distribution system may be classified according to the nature of the current. According to the nature of the current, the distribution system may be classified as first one DC distribution system, second one AC distribution systems. So nowadays AC component is universally adopted for distribution of electrical power as it is simpler and more economical than direct current methods. The specific gravity of aluminum 2.71 gram per cc is the lower than that of copper 8.9 gram per cc. Therefore, an aluminum conductor has almost one half the weight of the equivalent copper conductor. For this reason, the supporting structure for aluminum needed not to be made so strong as that of copper conductors. The aluminum conductor, being light, is liable to greater swings and hence larger cross arms as required. Third one is steel cored aluminums. Due to low tensile strength, aluminum conductors produce greater sag. This prohibits their use for larger spans and makes them unsuitable for long distance transmissions. To increase the tensile strength, the aluminum conductor is reinforced with a core of galvanized steel wires. The composite conductors thus obtained is known as steel cored aluminum and is abbreviated as ACSR, aluminum conductor steel reinforced. When the feeder ring is energized by two or more than two generating stations or substations, it is called interconnected systems. Figure below shows the single line diagram of interconnected systems, where the closed feeder ring ABCD is supplied from by two substations S and S at the points C and D. C at point C, the substation is S2 and at point D substation is S1. And this one is the feeder comprising of a closed feeder, that is ABCD. So from the branch AB, a distributor is there that is connected to the distribution transformer at the point R, then distribute the loads at different points. These are marked here. Similarly, at the branch CB at point O, another distribution transformer is there and which supplies the distributor to the different loads in a particular ways. Then from the point A and D, the power transformer is there and is connected as the point Q and distribute the different loads at these points. Then another distributor is at the point CD at point P. So again here another power distribution transformer is there which distribute the power at different loads. So in this way, this is a distributor which is interconnected distribution systems, that is a feeder rings energized by two or more generating stations here. The distributors are connected to the points O, P, Q, R of the feeder ring through the distribution transformers. The interconnected system has the following advantages. First one, it increases the service reliability. Second bit, any area feed from one generating stations during peak load hour can be fed from the other generating stations. This reduces reserve power capacity and increases the efficiency of the system. The types of DC distributors. The most general method of classifying DC distributors is the way they are fed by the feeders on this basis. DC distributors are classified as distributor fed at one end, distributor fed at both ends, distributor fed at the center, distributor fed at the ring distributor systems. The following points are the worth nothing in the singly fed distributors. A current in the various sections of the distributor away from the feeding point goes on decreasing, thus current in the distributor fed at one end. In this type of feeding, the distributor is connected to the supply at one end and the loads are taken at different points along the length of the distributors. This was the feeder and the feeder feed at point A, so that the arrow mark is there. And suppose the current pass through the loads at point C, then at the point D and the point at E. At point C, the load current is supposed to be I1, the point D, the load current is supposed to be I2, at point E, the load current is supposed to be I3. So this current nothing but is your I1 plus I2 plus I3. And at point C, the current is supposed to be I2 plus I3 because I1 current is there. Then at point D, I2 current is there, so the current is only I3 goes through the load terminal, load current I3 at point E. So AB nothing but a feeder. This feeder fed at only single end at the point A. So figure shows the single line diagram of DC distributor AB feed at the end A, known as singly feed distributors, and loads 11, I1, I2, I3 tapped off at point C, D, E respectively. The following points are not worth nothing in a single feed systems. The current in various sections of the distributor away from the distributing feeding points goes on decreasing, thus current in the section AC is more than the current in section CD. The current in section CD is more than the current in section D. So second bit, the voltage across the loads away from the feeding point goes on decreasing. Thus in the figure, minimum voltage occurs at the load point E. Third bit, in case of fault occurs on any section of the distributor, the whole distributor will have to be disconnected from the supplies. Therefore, continuity supply is interrupted. In this type of feeding, the distributor is connected to the supply main at both the ends of the loads and tapped off at different points along with the length of the distributors. The voltage at the feeding point may or may not be equal. Figure shows the distributor AB feed at ends A and B, and the load of I1, I2, I3 tapped up at the point C, D, E respectively. So this is the feeder AB feeds at point A, also feed at the point B. So taps at the point C, taps at point D, taps at point E. So I1, I2, I3 are the currents. Here the load voltage goes on decreasing as we move away from one feeding point, say, reaching minimum values, and then again start rising and reaches maximum value when we reach the other feeding point B. The minimum voltage occurs at some load point and is never fixed. It is shifted with the variation of load on different sections of the distributors. Its advantages: if a fault occurs on any feeding point on the distributor, the continuity of the supply is maintained from other feeding points. In case of fault on any section of the distributor, the continuity of supply is maintained from the other feeding points. The area of cross section required for a doubly filled distributor is much less than that of a single feed distributors. Distributor feed at centers. In this type of feeding, the center of the distributor is connected to the supply mains as shown below. It is equivalent to two single feed distributor, each distributor having a common feeding point and lengths equal to half of the total length. This was the distributor feed at the point AB, and this is the feeder AB, and I1 is the current between the I1 is the current at this point, I2 is the current at this point. At point C, the distributor is feed at the center. So center point, suppose the current is I1 plus I2 release here, I3 plus I4 release here. I2 current goes through this branch and I1 current goes to this branch. Similarly at point C, the I3 current goes to this path and I4 current goes through this path. The ring main system. In this type, the distributor is the form of closed ring shown in figure below. It is equivalent to a straight distributor fed at both ends and equals voltage. The two ends rings brought together to form a closed rings. The distributor rings may be fed at one or more than one points. This one is the ring main system. So the feeders at the point A, feeders at the point A, and these are the distributors. This is the load A I1, load I2 and load I3. Then uniformly distributed load at one end. Figure shows the single line diagram of two-wire DC distributor AB feed at one end A and loaded uniformly with I ampere per meter length. It means that at every 1 meter length of the distributor, the load taps is ampere. Let L is the meter length, be length of the distributor. On R ohm, the resistance per meter run. This is the AB and the currents are distributed in this point. This is feeding at point A. This is the length L. And second one is, suppose at point C length is L, point is AB, distributed AB and feeding at this point. So this one is the X distance between the midpoint of the distributor, and suppose consider dx is a small length. Consider a point C on the distributor at a distance x meter from the feeding point A as shown in figure. Then current at point C is I into L, that is equal to minus I into x ampere. So I like common I whole into L minus x ampere. Now consider a small length dx near the point C. Its resistance is Rdx and the voltage drop over length dx is V is equal to I whole into I minus x into Rdx. That is equal to I into R, L minus x into dx. Total voltage drop in the distributor up to point C each.